Hello viewers, welcome to another session of our preparatory e-learning class. We had started in this class with a whole lot of topics, and right about now, we want to see the concluding part of logarithm, which is equations of logarithm. So we have the first past question here, jump past question. You can also see it in WAEC, in the objective side. So we have to solve for x given that 2 log x base 10 plus log 2 base 10 is equal to 2. And this is an equation of logarithm. I can solve this in two ways so that maybe you choose any way that will be convenient for you. There are two methods of solving this. The first method, which I will call method 1, is by combining the left-hand side together. We had looked at addition law of logarithm, where when you have addition like this, you multiply the number here and this, you write one log and write one base. But move this coefficient that is 2 here to come on the log, because there is a law that says if we have log x power a base b, this can be moved to this side, or it can be returned back to a log x base b. So we are going to apply, we have log x power 2 base 10 plus log 2 base 10 equals to what? 2. You can see that the conditions are now satisfied, and then we apply the law of logarithm as we solve it. So what do we do to apply the law? We write one log, one base. Here we have x power 2. Because of plus, we have times, and then 2 equals to what? This side, we have 2. Now, x squared times 2 is 2x squared. So we have it there. We have log 2x squared base 10 is equal to 2. And recall this law. There's a law that says, recall, when you have log a base n is equal to x, if you want to make this a to stand as a subject, this is going to be, we have a is equals to what? N power x. As there is no log again, this x you have here will come on the base n, equating it to letter a. So recall this law that says log a base n equals to x. To simplify this, you have a is equal to what? N power x. So this is like saying our a, and this base is our n, and the 2 here is this x. So applying this law of logarithm, we have 2x power 2 is equal to the number here that you have on the right. It will come as a power on the base. So we have 10 power 2. So what do we have there? This is going to become 2x squared equals to 10 power 2 is 100. 10 times 10 is 10 power 2, which is 100. Now to continue, you divide through by 2, divide through by 2. We're now going to have 2 cancel 2. We have x squared remaining equals to 100 divided by 2. You have 50. So there we have x squared is equal to 50. How do you remove this square from x so that x can remain alone? If it was power 3, which is cube, what do we do to remove this power 3? For example, we take the cube root of both sides. So because it is square here, we take the square root of both sides. So taking square root of this side and taking square root of this side, you can see square root and square can cancel out. We have x remaining here. So square root of 50, if we are to simplify it according to our short form, we have breakdown. 2 goes to 50 is 25. And then 5 goes, we have 5. 5 goes, we have 1. So here we have 25 here as a perfect square. So square root of this perfect square number 25 is 5. But we cannot find square root of 2. So we can say this is going to be 2 times 25. You don't know the square root of 2. We leave it at that. Square root of 2. Square root of 25 is 5. So our answer for x is equals to what? 5 root 2 for the first method. Okay, let's look at method 2. On how to solve this. Method 2 is very straightforward. Just apply the law and you move on. How do we solve that? Of course, we know that when you have a number without log attached to it, you can introduce log to that number so that you can easily solve it. On the left hand side, you have log, and on the right hand side, you also have log. Anytime you have a number or a constant standing alone without log attached to it, you introduce log to it. Of course, you know, if you introduce log 10 base 10 is the same thing as 1. So if I introduce log 10 base 10 to attach to these two, it is the same thing as saying 2 times 1, which is the same thing as 2. So the introduction of log 10 base 10 has not changed the fact that 2 is still the constant there. It is just to bring in log in place of that 2. Okay, but take note that whatever log of a number and a base you want to introduce to attach to a constant, you consider the base. If the base is 3, it must be log 3 base 3. If the base is x, it must be log x base x. Now that the base is 10, we have log 10 base 10 to be equals to 1. As simple as that. So let's bring in this there. We have here, but let's move this one to come behind, to come on top of the number. We have log x power 2 base 10 plus log 2 base 10 equals to what? 2 log 10 base 10. It's the same thing. You introduce the log to the constant and consider the base. If the base is 3, you put log 3 base 3. If the base is 5, you put log 5 base 5. You must be consistent considering the base. So here we can apply our addition law. We write 1 log, 1 base, put a bracket. This is x squared. Because of plus, we put times, and then our 2 there equals to, we move these 2 from here to come on top of the number. We have log 10 power 2 base 10. Now continuing from there, we have, this is our log 2x squared. 2 times x squared is 2x squared base 10 equals to, here we have log 10 power 2 is 100 base 10. We can now see that the log on the left and the log on the right are the same, log base 10 and log base 10. They can cancel out. Once you reduce every log on the left to one log on the left, and you reduce every log on the right to one log on the right, having the same base, they can easily cancel out. So what do we have? We have the log 10, cancel out log 10 on both sides. What is left there? We have, let's bring it up here. We have 2x squared is equals to 100 that is left there. You divide through by 2, so that x squared can remain alone. This goes to this. You have x squared is equal to 2 divides 100, you have 50. To remove this square, we take the square root of both sides. So square root cancels square, you have only x is left. Now for 50, that can be simplified as 2 times 25. We don't have square root for 2. 2 is not a perfect square. So we leave it with a root. So we have x is equals to what? Square root of 25 is 5 root the 2 that we have there. But if the answer is in decimal, you can use a calculator to enter 5 times root 2 and you have your answer there. That's a simple solution for the first question, equation of logarithm that we have to solve. and we will look at another example of equation of logarithm. Let's look at our next example, which is one of our past questions on the equations of logarithm. This one says, if log 2x plus 1 base 10 minus log into 3x minus 2 base 10 is equal to 1, find x. If you look at this, to apply the law of logarithm there, we have subtraction law. There is no number here, exception of it visible one. There is no number here behind the log. No number here is behind the log, but we have the basis here as equal, so we apply the law direct. But over here, equals to 1, we know that log 10 base 10 is 1. Log of a number to the same base is 1. So we replace this 1 with what? Log 10 base 10. So solving this, in our solution we have log, apply the law of log here, we have 2x plus 1 divided by 3x minus 2 all into base 10 equals to, bring in log in place of this one, you have log 10 base 10. Of course, log 10 base 10 is 1. You can now see that in this equation, the left-hand side has log base 10 and the right-hand side has log base 10. What do we do? They cancel out. This cancel out this. And what is left there is 2x plus 1 all over 3x minus 2 equals to what? Only 10 is left. Equals to 10. We can say 10 over 1. Now to solve that, we say cross multiply. When you have a simple equation like this, you have a fraction and a number. To solve it further, you cross multiply. That means this 10 multiplies the denominator you have here. That is 10 into 3x minus 2 equals to 1 times everything here is everything there. 2x plus 1. Open the brackets. We have 10 times 3x is 30x minus 10 times 2 is 20 equals to 2x plus 1. How do we solve this further? We collect like terms. Collecting like terms means every term that has the same unknown, like 30x here and 2x here, you move them to one side, whereas the constant term, without having x attached to them, you move to one side. So we have here, let's move this 2x to come and meet 30x. We have 30x, here was positive, coming to this side, crossing this equal to sign, it becomes minus 2x equal to, here we have 1 already there. As this minus 20 is coming to meet 1, it is coming from minus to plus, plus 20. Now solving this further, 30x minus 2x is what? 28x equals to 1 plus 20 is 21. So what do we do to find our x? We divide through by 28. Divide here by 28. Divide here by 28. We now have this cancels this. Our x is now equals to what? 21 all over 28. 21 all over 28. And that is our answer to that.